Okay, so they've given us a question. Maybe this represents a profit of a company, a ball flying through the air. Who knows? Okay, but what we're gonna have to find out is, let's say they want us to figure out what the domain and range is. They want to know domain and range. They want to know max or minimum height. Maybe they also want to know what the zeros are. Max, min, height, zeros, domain and range. We can even throw in an extra question after. But what we're going to do is we're going to find these three things essentially in three different ways. Okay. Now the first way we're going to try is through factoring. Okay. So we're going to go through factoring. Now, what's funny about factoring is you try it out first because it can be a fast way to solve things. And specifically, when we factor, the first thing we will solve are the zeros. From there, we would work on the max and min height and then the domain and range. Okay. But the thing is with factoring is it doesn't always work. Now, in this question, we're going to do it. It is going to work in this one. And then we're going to go over two other methods that will always work. Okay. The reason we would possibly try factoring first is it tends to be faster once you get good at it. Okay. So the very first step to factoring is the greatest common factor. We look for a greatest common factor. Now, looking through all of these numbers, technically the number 2 comes out of everything. And because our a value, we're in standard form right now, okay? Yeah, is it negative? I'm going to take out the greatest common factor as -2s. And you know what? I'm going to relate this to the standard form just because when we go to do a third version, I want you to be able to draw similarities between them. So standard form is ax squared plus bx plus c. Are you familiar with that? Mm-hmm. Yeah, okay. So essentially I'm taking out our a as the common factor. It just happens to work like that. Okay, plus rc. So what that means is I'm going to divide each of these terms by the number -2. And what happens is -2 comes outside of the brackets. It's our common factor, you could say. Okay, so we have x squared, not plus, minus 6x plus 9. Okay. So if taking our common factor out, next step we're going to do is I'm going to work on factoring these brackets. So when I factor these brackets, I take the factors of the first term, which are 1x and 1x. Factors of the last term, well, 1 and 9, 3 and 3 are both options. Okay. Taking a look at this, yeah, exactly, good. Right away we know it's got to add up to -6x, and if we do 1 by 3, 1 by 3, 3x, 3x. But in order to make a negative, they will both have to be negative. And in other words, those are the numbers we multiplied by. -3, -3. Now, to make sure it works, what is -3 times -3? 9. There we go. And it's going to be positive. A negative times a negative is a positive number. So we know that that works because we have positive 9 here. So when we go to put this into our brackets, we have -2, our common factor. These guys are our first terms, 1x and 1x, or just x and x. And because they're the same, it doesn't actually matter which bracket the other two go in. So we have -3 and -3. Okay. So what we have here is, you could also say it is squared also. It's completely up to you. Yeah. So, or we can represent this with -2x minus 3 squared. Okay, so that looks like good. But the goal here, like we said, is we're actually trying to find the zeros. And zeros are our x-intercepts. Okay. So usually, with a lot of parabolas, we're talking about 2 x-intercepts. This one's going to be a little different, but it's fine. What we're going to do is we're going to try to solve this. An x-intercept is when y is equal to what value? Do you know? If we're talking about, 0. Yeah, exactly. We're talking about when y is equal to 0. So in other words, f at x technically represents our y. We're going to replace this with 0 because we're trying to find the zeros. So I have 0 is equal to -2. Minus 3. And technically it can be squared. We're just going to leave it like this just so you can see the normal process if these numbers have been different. Now, this -2 here, technically, think of these brackets as a term in themselves. And I'm multiplying -2 by some number by some number. But in the end, that number is going to equal 0. Well, The only way to get 0 is to multiply by a 0. No other numbers multiplied by themselves create a 0. So there's two ways to think about this. We know negative 2 is not equal to 0. I can kind of drop them off the equation. Another way to do it is just by simplifying. Let's just move this negative 2 to the other side. If I divide this side by negative 2 and this side by negative 2, these two negative 2's create a 1, or usually they commonly say they cancel each other out. Okay? Technically it creates a 1, but we'll just keep going with that. 0 divided by negative 2 is still just 0. Okay, so now we're left with 0 is equal to x minus 3, x minus 3. So anytime you need to get rid of the common factor, it pretty much drops off itself when we're dealing with the number 0. Okay. Now, what this says is this term times this term is 0. Well, let's test them both. Let's say I want to figure out what they would both be at 0. So we go x minus 3 equal to 0. You're taking a FOIL. That takes longer. We're actually already in factored form. So I'm breaking it into two different equations. 0 is equal to this bracket in itself, because if this bracket ends up being 0, then for sure this whole thing will be 0, because it's 0 times a number. Or this bracket equal to 0, because if that bracket's equal to 0, when I multiply, I'll again get 0. That's the idea here. Now, because of what we have here, the numbers are going to be the exact same. X is going to be equal to 3, okay, in both cases. So what this is saying is there is actually only one 0 or one x-intercept. It's at the number 3. So we go back over here. Oh, that worked out pretty good. It's at the number 3. So we have some parabola, and it's actually, a is negative, so it's going downwards. We have some parabola that goes like that, and it's just tangent to the x-axis at 3 and 0. That's what the zeros of this are. Okay? Because it worked out that way, I could have probably chose a different question. Our max is obviously the tangent point here. Our max is going to be at 0 in this case. I wish we had another example. Let's say for argument's sake, now I'm just going to throw this in as a second example. Okay. Now technically this would end the question here. This one becomes very easy. Our max, because the highest point is that x-intercept, the max of the parabola is going to be y at 0. Okay, that's the highest point it got to when we drew our rough sketch over here. And the domain and range. Well, this is a parabola. We didn't say there was any restrictions on it, so the domain will go left and right forever. So the domain is x is every real number. There's no restrictions. And the range is x is element of all real numbers, such that y, though, has to be less than or equal to the max point, which is 0. So that's how we represent it as domain and range. Now, what I'm going to do is just quickly here, I'm going to split off because I want to show you an example when the brackets are different. Let's say we had 0 was equal to x plus 2, x minus 5. Okay? Say we found that out in factored form. Okay? I know that's not exactly. We're going to try to separate this so when you go back through your notes, you don't get confused. It really has nothing to do with that part of the question, but I want you to realize that there would be more to this. So at this point, we had split them into two equations. We're going to do the same thing here, but we're going to get different numbers this time. 0 is equal to x plus 2, and 0 is equal to x minus 5. So our zeros will be x is equal to negative 2, and x is equal to positive 5. So now what I'm getting is two different points, which is a common trait in parabolas here. And the 2 points seem to be at negative 2 and positive 5. Okay. Now let's say, I guess technically this equation, I should write it out in your standard form. We'll say that it was x squared plus, no, minus 3x. This is what this guy would be in. Minus 3x minus 10. That's what he would have been, and we factored him to get to this, okay? So he was a positive parabola, so we did something like this. Comes up and down, because our a value was positive. It was just a number 1 in this case, okay? We didn't have to take a common factor out of it. So we have our parabola, and we got our points there. But the second question said, find the max or the min. Well, is this going to have a max or a min, this parabola? It only has one. It's either a max or a min. Minimum. Yeah, because it opens upwards. So the lowest point would be a minimum. It has the lowest point. It doesn't have a max. It goes on forever upwards, this parabola. Okay? So, to find the vertex from factored form, there's a little thing called the axis of symmetry of a parabola. Okay? So, axis of symmetry. And the little formula for that, I'm going to call it AOS, is equal to what they call is R plus S divided by 2. R and S are your x-intercepts. So what they're saying is if you add the two x-intercepts together and divide by 2, you will find the axis of symmetry. So in this case, that's negative 2 plus 5 divided by 2. That's going to get us 3 divided by 2, which is 1.5. The axis of symmetry is also the x value of the vertex. And the reason being for that is the axis of symmetry is an imaginary line through the middle of the parabola. And because it goes directly through the middle, that's technically where the vertex is, because it's a symmetrical shape. That would be the lowest or highest point. So we're saying the x value is 1.5, and we've got to find the y value. Well, in order to find the y value, I plug this x value into either the factored form for the x's and solve for y, or into our standard form. Either one works. Let's do it into our factored form, because that's kind of where we created this thing from. So our factored form was f at x was equal to x plus 2 times x minus 5. Okay. Now if there was technically a common factor here, I would have had to put it in, but we didn't have one in this case. So our x value is 1.5 or 3 over 2, depends if you want to leave it as a fraction. So we plug it in. F at 1.5 is equal to 1.5 plus 2. 1.5 minus 5. Okay? Is that the original thing we started with? Yeah, plus 2 minus 5. Good. So, what we're going to find here, 1.5 plus 2 is going to be 3.5. And in this one here, 1.5 minus 5 is actually negative 3.5. Yeah, they're multiplying, right? And this is usually a good way to indicate where it is. See how these absolute values are kind of the same? Well, that makes sense because we took a number that should have been right in between the two of them. So one should have been positive, one should have been negative. That's a general thing that tends to happen with these. So 3.5 negative times 3.5, negative 12.25. Negative 12.25, which is my y value I've just discovered of the vertex. So, when I go back up here to our imaginary one, it's negative 12.25. I know that doesn't look so nice, but that's the vertex of this, or the minimum. That's our minimum point when y is equal to 12.25. So we found our zeros, found that domain and range. Let's talk about domain and range. Domain is what for this thing, left and right?
All real numbers.
All real numbers. What's the range going to be?
All real within, or except it has to be less than.
Less than? Yeah, greater than. It's got to be greater than negative 12.25. So, domain, just like you said. Domain is x is all real numbers here. And the range was y, all real numbers, such that y is greater than and equal to negative 12.25, which is our minimum point. So, a whole lot done there. Okay, I know we kind of branched into a second question, just because I want to show you.
Yeah,
this was kind of
yeah,
that's one was very easy. This is more common, what you'll have to do.
Mm-hmm.
Okay, so there's quite a bit to that. Now that would be doing it through factored form, but there's other ways to solve this. All right, so we have another equation. We could have done this one also by factoring, but let's just say we're in standard form right now, and you want to complete the square. That's the process of changing something from standard to vertex form. In other words, we have our standard form f of x is equal to ax squared. Whoops. Want a to be read here. Ax squared plus bx plus c. And vertex form is f of x is equal to a times x minus h squared plus k. I know I haven't written those things in yet, but a and a, this is important that we have at least one a in there. B and h, those are different. And c and k. Okay. Now I want you to notice a similarity here. Vertex form has an a and standard form has an a. What that's saying is those two numbers are going to be the exact same. So right away, when going to vertex form, I know what my a is going to be.
Not the negative, it's the 2. So.
Yeah, it's going to be that 2. Now we're going to complete the square here to do this. Okay, and completing the square is kind of a process to it. But we're trying to create a perfect square trinomial, which actually kind of relates to the other one. So completing the square. We are going to divide the first two terms by our a value. Okay, our a value happens to be 2. So we're going to divide both of those first two numbers by 2. So we're left with 2x squared plus 3x minus 8. So right away in vertex form, a is 2. We've already figured that out. And we already knew that was going to be the case. Now what we do is we take this number here and we divide it by 2 and square it. Okay, kind of like b divided by 2, it's our new b squared. So that becomes 3 divided by 2 squared. Now, now 1.5, we could work in decimals or we could work in fractions. I'm going to tell you, I know not everyone's great with fractions, but it'll actually be easier if we know our fraction rules to work backwards when we have to later on in this question. So I'm going to keep this in fraction form. And what this really says is 3 over 2 times 3 over 2. When I multiply those fraction rules, I get 9, 3 times 3, over 4. Okay? So I need to add and subtract 9 over 4. I'm going to do that. I'm actually going to keep it in fraction form just so you see how this becomes easier. X squared plus 3x, and I'm going to add 9 over 4, and I'm going to subtract 9 over 4 because it's like creating a 0. It doesn't really change anything. Now,
okay, but what's the point of doing that? Like he's done that in class, but I don't get it.
We're trying to create a perfect square trinomial. And I'm going to show you what that is in a second. Okay. Now, in order to do this perfect square trinomial, the negative version needs to actually end up outside of the brackets. Okay. And in order to do that, I actually have to multiply by my a value when I bring it out. And the reason being is, if you remember distributive property, if there's a number in front of the brackets, technically I have to distribute it to every term. But I'm not actually taking the other 3 terms out. I'm only taking out the last term.
Okay.
So in order to keep it clear, I have to multiply it by the a. Does that make sense?
Yep.
Okay. So the next line reads 2x squared plus 3x plus 9 over 4. Now, when I multiply negative 9 over 4 times 2, he can be written as a fraction. And when multiplying fractions, we do the top numbers by each other and the bottom numbers by each other. So this is actually still not that difficult. Negative 9 times 2 is, well, yeah, exactly. Negative 18 over 4. Good. I'm glad you got that. Minus 8. Let's leave what's on the outside for now. What they want us to focus on here is is a perfect square trinomial. Now, technically what we're doing here is factoring this. I'm going to factor it, and then I'm going to show you the shortcut to doing this. Okay? You definitely don't have to factor every time, because the steps we took created a special polynomial here. So say we're factoring this, and I'll do it in red. Just focusing on this right now, okay? There we go. X squared plus 3x plus 9 over 4, okay? Now, this actually becomes a little difficult because we have a fraction here. Factors of this guy are 1x and 1x. Now, factors of a fraction. We don't normally work with that when we're factoring, right? But I'm going to tell you there's going to be a set right here that's going to work. Technically, 3 over 2 and times 3 over 2 are factors of this, okay? And what I want you to look at is, remember our rules. They need to add up to the middle term, which is 3x. Well, if I multiply across, I'm left with 3 over 2 plus 3 over 2, okay? And this is like 1.5 plus 1.5, right, in decimal form. You definitely do not have to do this, okay? I'm just kind of proving it to you. What is 1.5 plus 1.5? 3. So that works. So what has happened here, these will be my first terms, x and x. My other terms are plus 3 over 2 plus 3 over 2, which is represented like x plus 3 over 2 squared, correct? Okay. So what I mean by a perfect square trinomial is the two brackets end up being the exact same. The reason we do this is we can represent it with the squared, and in vertex form, we have a squared up here. The goal is to get two brackets that are actually the exact same. So the fast way to do this, you definitely don't have to do this every time, and the reason I told you to keep it in fraction form is because the fast way to do this is to actually just square root both these numbers. The square root of x squared is just x, which is my first term. And the square root of 9 over 4 is 3 over 2, which is our second term.
How do you know the square root?
That is, the reason we're square rooting it is because we've created a perfect square trinomial. And what that is technically we've created a polynomial that can be represented like this. Now we're getting a little complex here, but it can be represented like a squared x squared plus 2ab x plus b squared. What that means is if I square root the first and the last term and then multiply them by 2, it will equal this middle number, which is exactly what we did. I square rooted 9 over 4, gave me 3 over 2. 3 over 2 times 2 is 3, which is our middle number. Just know, okay, you don't have to go through all this proof. Just know that once we get to this step in completing the square, all I have to do is square root the first and last term to find out what's in these brackets. So in other words, I square root the first and the last term. Square root of x squared is x. Square root of 9 over 4 is 3 over 2. So I put them in here. I put a squared on the outside. Now here's the trick. This middle operation, whether it's plus or minus, you bring that down. So because it's a positive, I put plus in. Had it been a negative, I would have put a negative in there. Okay? Because it's plus, it's plus. And on the outside of this, we still have negative 18 over 4 minus 8. Okay? Now, this is the only tricky part. I actually need to equate this. Negative 18 over 4. Oops, wrong button. Let's get a calculator out here quickly. 18 divided by 4. Yeah, 4.5. Okay? So that says negative 4.5 minus 8. 2. X. I can either say this is 1.5 now, if we want, because I know you're a little more used to decimals. Minus 4.5 minus 8. Here's our vertex form. There was a whole lot we did there, right? Negative 12.5. Now, I just want to recap. I did this the long way, just so that you understand this. Now, I know it's not the clearest, especially because we had fraction involved. But what it is, if we created something special where we can just represent it by one bracket, right? We only need the one bracket. And in order to be in vertex form, we need to have only one bracket. Okay? But remember, this question asked us several things. Now, in the vertex form, they wanted our domain and range, they said. They wanted the min or the max, and they wanted the zeros. Now in factored form, the very first thing we find is the zeros, but that's not the case in vertex form. In vertex form, the very first thing we find is the max or min. In this vertex form, looking at this question, what is our vertex? Do you know by looking at these numbers down here? Well, remember, this represents H. This represents K. Yes, good. So the vertex is my X. Negative 12.5, my Y value. Not quite. It tells you exactly in here.
Or is it 1.5?
Well, it's actually the opposite of what's in that bracket. Because it says, yeah, it's going to be negative 1.5. Okay. So negative 1.5 is our vertex. So we have our vertex now, which means we have a max or a min. Our A value is positive, so that means we have some parabola that opens upwards, right? It opens upwards, and the vertex is actually at negative 1.5 and 12.5, so somewhere down here. And it goes up like this. Okay? because our a value was a positive number. We know it opens upwards. So we found the min, which means I can solve the domain in range first instead. The min value is y at negative 12.5. That's our minimum, right? Because it's the lowest point. The domain, well, just like most parabolas, unless they gave us a specific restriction we're making it, XER. I'm going to be real, such that negative 12.5. Good, you're exactly right. Now, here's the tricky part here. This is where we kind of get confused a lot of times. We're in vertex form, which means I only have one major variable. Where in standard form, this is why we don't use standard form, I have an x squared and an x. It becomes very difficult to solve things. In fact, almost, well, unless you know some other type of math, it's almost impossible for us to solve this with two different variables, one being a square. What we're going to do here is we only have one variable now. Zeros talk about when y is equal to 0, or the x-intercepts are when y is equal to 0, right? So, and looking at this, we're going to have two of them. So we've got to find the x values, and we already know the y value is going to be 0. So this equation in vertex form is f at x is equal to 2x plus blah, 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 blah. F at x represents our y. So I'm just going to slide over here so we have some room. What that means is I'm going to replace f at x with 0. That's our y value. So I'm now left with 0 is equal to 2x plus 1.5 squared minus 12.5. Okay? So now, all I have is one variable left. Let's solve for x. We have 0, first thing we're going to do, reverse BEDMAS. Let's move negative 12.5 over. So we get 12.5, it's positive on the other side, is equal to 2x plus 1.5 squared. Again, reverse BEDMAS. Technically, the last thing we'd be doing is this multiplication, but because we're isolating, it's the first thing. We need to move that 2 over. So I'm going to divide both sides by 2. Yeah, very good. 6.25 is equal to x plus 1.5 squared. Okay. The over 2,
oh, because it's
yeah, kind of cancels out. Now, in order, the next thing to do, technically we would do brackets, then exponents, so we're going to deal with the exponent. To get rid of this exponent, I square root.
Okay, that's where I get lost, because I don't know why you have to square root anything.
The reason we square root is because the opposite operation of to the power of 2 is root 2. Now, I know they don't usually write it in, but there's a 2 root. That means square root is the opposite of the power of 2. So root 2 is the opposite of x squared.
Yeah,
In other
it's only squared on one side.
It's only squared on one side. And just like there was only technically a negative 12.5 on one side, technically I didn't move it over. Actually what I did is I added 12.5 to this side, and I added 12.5 to this side. What happened here is we got what's commonly known as a cancellation, or what it is we created a 0. And over here it actually equaled something, just like I did here. I divided both sides by 2. Whatever you do to one side of the equation, you must do to the other. So because we're square rooting this side to get rid of this guy, I have to square root the other side of the equation. This is a balancing technique anytime you're doing this. So the square root of 6.25. Oh, it's 2.5. Nice. So we get 2.5 is equal to, those square roots dropped off, x plus 1.5. Well, I just got to move 1.5 to the other side or create a 0. Technically, I'm subtracting both sides by 1.5. So 2.5 minus 1.5 equals x. Sorry, I did make one quick error here. I meant to write this out. Technically, the square root of 6.25 has two answers. I don't know if we talked about this before. It's technically positive and negative 2.
Oh, yeah.
So, this is where I made a mistake. Sorry about that. Because it's positive and negative 2, I have to split this. And remember, we did a splitting before. We split with the quadratic formula because we have a plus and a minus. And when we're factoring, we split equations. Whenever we're trying to find zeros, we're usually looking for 2 zeros. So I have to carry this process out with positive 2.5 equals x plus 1.5 and negative 2.5 is equal to x plus 1.5. Just like in the quadratic formula, remember we split that also?
Yeah.
So now, I move that over, we get 2.5 subtract 1.5 equals x, and I get negative 2.5 minus 1.5 equals x. I know it's lagging a bit there. We'll wait for it. Over here, we get 1 is equal to x. Over here, we get negative 4 is equal to x. Or in other words, those are our zeros. Our x-intercepts are 1 and negative 4. So we jump back up here. Here's 1 and 0 and negative 4 and 0. Now you're right. We can add them in.
Oh, but we don't need to.
But we don't need to because we already have it. Okay. We've gone about this the other way. Okay. So our zeros are there. These are the two zeros in the equation. We already found the mean range. We already found the minimum. We've done everything there. This is essentially two different ways of solving a question. We did it by factoring on the left here, which is quite a process. Or we completed the square to find the max and the min first, and then found the zeros after that. Okay, so we did it. Yeah, we did it the long way, so I'm going to shoot through this quickly. First step, take the a value divided by the first two terms. Our a value is negative 5, so I divide both of these by negative 5. The negative 5 is now the a value of our vertex. Inside we're left with t squared minus 6t plus 10. Now this is our new b value, you could say. And what we're doing is we're taking b divided by 2 and squaring it. So our new b value is negative 6? Sure. Negative 6 divided by 2 is negative 3.
Wait, why are we dividing by 2 again?
It's just part of the process. Remember that little formula, b divided by 2 squared. That's important. Okay? So we divide it by 2, and then we square it. Well, negative 3 squared is 9. And we're adding and subtracting 9 inside this equation.
So inside the bracket.
Yeah, so negative 5. We get t squared minus 6t plus 9 minus 9 plus 10. Now remember, I need to move the negative version out. And when I move the negative version out, I have to multiply by what? Yeah, negative 5. So, negative 5 t squared minus 6t plus 9. Negative times negative is positive. 45 plus 10. Good. Got that so far. I can equate on the outside if I want. T squared minus 6t plus 9 plus 55, right? That's my k value. So right away I've discovered two things. Remember vertex form? Here's our k value. Here's our a value. Last thing we're looking for is h. Well, here's the fast way to do it. I've created a special number by using this formula. Because I use that formula, this special number, I can factor these brackets by just square rooting the first and last term. Square root of t squared is t. Square root of 9 is technically plus or minus 3, but what we're going to do is we just want the absolute value, 3. Okay? So, in our final form here, we factored it, and we know it's a perfect square trinomial, so we only need to represent it with one bracket. The first term is the t, the second term is the 3, and because this is a negative, I bring that negative down. So there's your completed square. And again, that's our h, right? We have our h, our k, and our a. So the trick to this is, remember, because we use this, we can square root to really just find out what these two numbers are going to be.
No, that's it.
That's it. And now you have them.
You have the points.
You have your vertex, yeah. And then you would work from there to